For problem number 3, how far could a cyclist travel in kilometers or kilometers in 2.5 hours along a straight road if her average velocity is 18 kilometers per hour? Keep in mind that 18 kilometers per hour is roughly 11 miles an hour. Okay, so let's think about this. Once again, let's read this again. How far can a cyclist travel in this much time along a straight road if her average velocity is this? Okay, so let's say that the cyclist is starting right here, and we're trying to figure out, hey, how far could the cyclist travel in a certain amount of time? Let me ask you something. If you're starting right here, what would you say that the initial position is of this person? What would you actually say to this? Let's just say that's going to be equal to 0. And we're doing this in kilometers. So I'm just going to write that it's in kilometers. So looking at this, what does this 2.5 hours represent? Oh, that's our delta t. Okay, I know that we actually were saying before that we were going to be using meters and seconds, but as of right now, it looks like kilometers and hours. Let's see here. And then it says the average velocity is 18 kilometers per hour. Okay, so our average velocity is 18 kilometers per hour. Hey, being that we're actually using kilometers and hours in every single part of our problem right now, that's okay, because it's like one of those things where the units, they will just work with each other. We can't really mix and match between using kilometers and meters per second or meters and kilometers per second. We really can't mix and match. But if all of our units are, we have kilometers here, kilometers per hour here, and we have hours over here. Hey, you know what? Those are all kind of like aligned with each other. That's one of those situations where you're like, hey, I could just work with this here. These units look like that. I'm not really crossing between hours and kilometers per second and just really mix matching my units. We're just staying consistent over here, and that's okay. We could do that. This is one of those situations where you could just be not having to use meters and seconds and meters per second units and everything. So, and it's asking us, how far can the cyclist travel? That's what the question is. So if the cyclist is starting over here and ending up over here, well, isn't that just simply the final position, how far the cyclist is going to travel? So that's what we're going to be finding right now. And if we're looking at our formulas, once again, we were given an average velocity. So therefore, which formulas do we want to be using? Hopefully you're saying that we want to be using one of the first two formulas, being that has to do with the average velocity. So which one of these formulas do we want to use? Well, we don't have our initial velocity or final velocity. So once again, we're just going to be using this one right now. I know that this seems a little repetitive and everything, but these are different principles, different kind of concepts that I want to be covering in the first few problems before actually getting into the thick of it and everything. So, okay, so we just simply plug this in. And what do we have here? So we have our 18, that's our average velocity. Our final position, that's what we're trying to find. Our initial position, which is 0, divide that by 2.5. The subtraction of 0 doesn't provide any sort of value. Being that we have a division of 2.5, what do? We multiply both sides of the equation by 2.5, and we get our final position of 45 kilometers. And that's the final answer for that one. Usually, once again, our position is typically in meters, but being that we were consistent with our kilometers over here, our final answer will be in kilometers.